So hello everyone, today we are going to start the chapter Unit and Dimension. This is the lecture 1. I have just divided the total chapter in 3 lectures. In the first lecture we'll just cover the fundamental and the derived quantities, the dimensions and how to represent the quantities in different forms. Okay, so let's start the chapter. So now we have to learn that what are the different types of quantities we have. Some of the quantities are measurable, they are known as a physical quantities, and the quantities which are not measurable, they are known as non-physical quantities. Like you can say that the length of an object or the mass of an object you can measure, even the velocity, temperature, area, volume, density, these all the things we can measure, right? Length is measured in meter, mass is measured in kg or gram, velocity is measured in meter per second or kilometer per hour, temperature is measured in Kelvin, area is measured in meter square. Like that we can measure these physical quantities, right? But there are some other physical quantities which are cannot be measured, and they are known as a non-physical quantity, like the sand or the water in a particular river, the road, and the population of Mumbai. That's some of the examples I have taken here to make you understand the concept of non-physical quantity, because these things are not measurable. Okay, so now we are proceeding to the next slide. That is, there are the classification of physical quantities. All the physical quantities which can be measurable, they are classified as fundamental physical quantity and derived physical quantity. So at first we are going to learn that what is fundamental physical quantity. Fundamental physical quantity is a one type of physical quantity which is not depending on the others. Suppose I can say that the length of an object or the mass of an object, even the time, they are not depending on the other physical quantities, so they are the fundamental physical quantity. Whenever you have to find out any other physical quantity, you need the help of length, mass, or time. Even there are 7 fundamental physical quantities. They are like length, mass, time, temperature, amount of substance, luminous intensity, and current. So there are 7 fundamental physical quantity. They are length, mass, time, temperature, amount of substance, luminous intensity, and current. Okay, we have just made a table to make you understand that we have to remember the symbol of these 7 fundamental quantities and their unit as well. Okay, because whenever you are going to measure any fundamental quantity, you need some unit. It can be a cbse unit, it can be a SI unit, or a FPS unit. We will study the system of units as well. Okay, now let me talk about some derived quantity. These are the physical quantities which are depending on the fundamental physical quantity. For example, if I can represent the speed, speed is equals to what? It is equals to the distance covered in a particular interval of time. So this distance is a one type of length, and the time also. These two are the fundamental physical quantity. So to represent the speed, I need the help of the distance and the time, which are the fundamental physical quantities, right? So we can say whenever we have to represent any derived quantity, that will be based on the fundamental physical quantities. Now we can see that this is the required table, by studying which you can remember the SI unit of the 7 fundamental physical quantities and their symbol as well. Like the length is expressed in meter and it is having a symbol of m. Mass is measured in kilogram and it is having a symbol of kg. Time is measured in second and it is same for all the system of units. Okay. Temperature is measured in Kelvin, it is represented by K. Electric current is measured in ampere and it is having a symbol of A. Luminous intensity and amount of substance. These two things are not so much of in use, so that's why you can simply remember them. But the above quantities, whatever I have already discussed, that is length, mass, time, temperature, and electric current, these quantities will be in use in the class of 11 and 12 as well. So you have to remember these five fundamental physical quantities the most, because their SI unit, their symbol will be used everywhere. Okay. Now there are two other fundamental quantities which are actually known as supplementary quantities, because whenever we are just classifying the physical quantities, there was the two classification. One is actually the fundamental physical quantity, another was derived physical quantity. But some of the authors are also classifying the physical quantity as a fundamental, derived, and supplementary quantities. Okay, so let me talk about the supplementary quantities. These are the quantities by which you can measure the particular angle. It may be the plane angle or it may be the solid angle. The plane angle is measured in radian, solid angle is measured in steradian. But what I mean by that, plane angle, suppose from your very childhood you are able to draw 60 degree, 90 degree. The plane angle can be formed like that. With the help of two lines, you can easily form an angle. Suppose it is 45 degree. Now, if we have to form another plane angle, we'll just align the two lines and there is an angle between them. Suppose it is of 30 degree. Okay. In this way, you can make the plane angles and it is measured in radian. Okay. Though I have represented in degree, that is a 45 degree, 30 degree, how to convert them in radian? We know a formula that 180 degree equals to pi radian. So 1 degree equals to pi by 180. Now 45 degree equals to pi by 180 multiplied by a 45, right? So equals to 45 ones are 45, this is 45 fours are. So 45 degree, that means of pi by 4. Even you can say 30 degree equals to pi by 6. These are the plane angles in radian. Okay. Now let's talk about the solid angle. What I mean by solid angle? Now for that I have a question. Now have you ever eaten watermelon? Now whenever you are just going to the market to buy the watermelon, the fruit seller is selling that fruit and they have cut a portion like that. So we can say that with respect to that portion, whatever the angle is created at the center of that spherical surface is actually the solid angle. The solid angle can be represented by omega. Okay, the W type thing, that is actually omega. It is equals to the surface area that is created whenever they have just cut that portion. I am talking about this much surface area. The surface area divided by of. In this case, the radius of the spherical surface, it is equals to r. We are assuming that. So W is equals to S by of r square. So here solid angle omega, it is equals to the surface area created by the angle divided by radius square. So this formula you have to remember. Sometimes 1 mark questions are being asked with respect to this solid angle. Okay. Even in the case of plane angle also, we can formulate this thing. Now we can say that whenever two lines are aligned with that, they are creating an angle of 45 degree in the first example. So we can join the two lines by an arc, right? Now my drawings are not so much of good, but you can assume that thing or you can draw also. Okay. If you are joining these two lines with an arc, you can say the length of the arc. Okay. In this case, the length of the arc, that is equals to L. The radius, in this case also, the radius we are saying it is equals to R. And the angle created, it can be treated as theta. Again I am saying, suppose you have created an angle of 45 degree and you are just joining the two lines with an arc. The length of the arc is represented by L, the radius is represented by R, and the angle formed, it is represented as theta. Okay, so I can say that L is equals to R multiplied by of theta, and you can say that theta is equals to L by R. So here theta is the plane angle. It is equals to the length of the arc divided by the radius. So whether you are finding out any kind of similarity between the plane angle and solid angle, that theta is the plane angle, it is equals to the length of the arc divided by the radius, and omega is the solid angle, it is equals to the surface area divided by r square. Okay. In this case, if you are having any of the doubt, you can say. So we are moving in the next slide. Now, derived physical quantities are those physical quantities which are fully dependent on the fundamental physical quantity or on some other derived quantity, right? For example, if I find out the expression for force, so force is equals to what? It is equals to the mass multiplied by the acceleration, right? So the force is depending on the value of mass as well as on the value of acceleration. We know that mass is a fundamental physical quantity, but the acceleration, it is a derived physical quantity. So we are finding out the value of force which is depending on one of the fundamental physical quantity as well as on other derived quantity. So let's take some other examples to understand that. Now there we have just made a table for your convenience, that the velocity which is represented as a displacement by time. So the velocity is depending on the displacement as well as on the time. Similarly, acceleration is represented as change in velocity with respect to time, right? It should be change in velocity, just make it correct, just a typing mistake. It should be change in velocity with respect to time. So in this case, whenever you have to find out the value of acceleration, you are depending on velocity, which is a derived quantity, right? So in all of these examples, we are just making you understand that the derived quantity is fully dependent on other fundamental physical quantity. Otherwise, they are depending on other derived physical quantities, right? So now there are some important derived quantities which are being asked in your exam. They are actually asking the SI unit of that particular quantity. So you have to remember the mathematical expression as well as the SI unit. Because in the case of velocity, it is represented as displacement by time. The SI unit of displacement is meter. The SI unit of time is second. Acceleration is represented as change in velocity with respect to time. The unit of velocity, it is equals to meter per second divided by the time, which is having a unit of second. So finally we are getting the unit of acceleration as meter per second square. Now work done is represented as force multiplied by of displacement, right? So the force is having a unit of Newton and displacement is expressed as meter. So work done is having an SI unit of Newton meter, otherwise joule. It is represented as simple J, or you can write down the full form also. Now the last one, that is a pressure. It is represented as a force upon area. So the force is having an SI unit of Newton and area is expressed as meter square. So in this way we can learn some of the important derived quantities. There are other derived quantities as well. Suppose I am talking about the density, right? Density is expressed as mass by a volume, right? So mass is expressed as a kg. That means the SI unit of mass is kg and the SI unit of volume is meter cube. So the density is expressed as kilogram per meter cube, the SI unit, right? Similarly, we can find out the power. Power is expressed as work done per unit time. The work done is having an unit of joule and the time is expressed in second. So the power is represented, or it can be measured as a joule per second or watt. Okay. I hope these examples are clear. Velocity, acceleration, work done, pressure, density, power. Okay, all clear. Up to that, if you have any of the doubt, you can ask me personally. Otherwise, you can ask me in the group also. Not an issue. Okay. So now there are the units and the system of units. There are the three system of units. One is FPS, foot, pound, second; CGS, centimeter, gram, second; MKS, meter, kilogram, and second. Foot is actually used to measure the length. Pound is actually used to measure the mass, and always the second is used to measure the time. In CGS, you know it very well. From your very childhood, you are able to learn all this. CGS, MKS, FPS, right? They are already included in your ICSE syllabus. That means whenever we have to measure the length, we can measure length in a foot, in FPS unit. It can be measured as a centimeter in CGS unit, and it can be measured in meter in MKS unit. Okay, so let's understand each of the system of units separately. Okay, now this is the CGS unit system where the length is measured in centimeter, mass is measured in gram, and time is measured in second. Now the MKS unit. MKS is actually known as SI, right? According to the MKS unit system, the length is measured in meter, mass is measured in kilogram, and time is measured in second. The symbol of meter, it is actually represented as M. The symbol for kilogram, it is actually represented as kg, and for the second we represent it as S. Okay. Now there are some of the conversion that I think that you should know. That 1 centimeter, it is equals to 10 to the power minus 2 meter. You will say it is equals to 1 by 100 meter, but we can say it is of 10 to the power minus 2 meter. Even 1 micrometer, it is equals to 10 to the power minus 6 meter. 1 nanometer, it is equals to 10 to the power minus 9 meter. 1 picometer, it is equals to 10 to the power minus 12 meter. Okay. Now sometimes it is also represented as, suppose I'm measuring the power. Okay. In that case, I will say that the in a power plant, the total power produced, that is equals to 12 megawatt. The meaning of this capital M, that is equals to 12 into 10 to the power 6 watt. Okay. Suppose I am saying it is equals to 14 kilowatt. It is equals to 14 into 10 to the power 3 watt. These are the examples that I thought that you should know, because sometimes in the measurement of different physical quantities you need them. Okay. So now let's proceed with the next one. FPS unit. That means in FPS, the length is measured in foot, the mass is measured in pound, and time is measured in second. Now you should remember one thing, that 1 foot, that is equals to 3.3 meter approximately. 1 pound, that is equals to 2.2 kg. The conversions are essential. Sometimes for 1 mark question they are also can be asked. Okay, what are the type of question that may be asked in your exam? I will obviously discuss in the group. Okay, now the dimensions and their symbol. Now there are different physical quantities are there, right? Sometime whenever we have to measure the length of a particular object, we express it in meter. Suppose 20 meter, 14 meter, 18 meter. So this is a one dimensional quantity. Suppose we have to measure the area of a particular object, it's a square. So in that case, we express the area as a meter square, right? So it is a two-dimensional quantity, because to represent them, I need the length as well as the breadth. Suppose if it was a rectangle, then in that case, I will write down the area as a length into breadth, that much meter square. So whatever the exponent you are just writing down, which represent the dimension of that particular quantity. In the first example, the length was measured in meter, so it was having an exponent of 1. So that's why it is a one-dimensional quantity. Whenever I'm finding out the area, I'm just using the exponent as 2, meter square, centimeter square. So this 2 represent that it is a two-dimensional quantity. Similarly, whenever I'm measuring the volume, that exponent 3, it is representing that it is a three-dimensional quantity because I need the length, the breadth as well as the height. Okay. Now we are going to understand what is actually the dimension and what are the dimension of the fundamental physical quantities and what are the dimension of derived physical quantities. These are the basic things. So the first chapter is completing all of the basics needed to complete the total class 11 syllabus. Now, what is actually the dimension? That means power to which the fundamental quantity must be raised. That means in the previous slide, whatever the portion I have discussed, that means you can say whenever the length was represented in meter, it was having an exponent of 1, which represent it is a having a dimension of 1. It's a one-dimensional quantity. The exponent of 2, it represents it's a two-dimensional quantity, and the exponent of 3, it represents the three-dimensional quantity. Now, whenever you will just represent the dimension of any particular object, it can be expressed as LMT form, otherwise MLT form. What is this LMT or MLT? Now, the length is having a dimension of L. The dimension of length is L. The dimension of mass is actually represented as M, and these are represented within the third brackets. Now the dimension of time, it is written as T and it should be in a third bracket. Okay, so that's why any of the physical quantity, it may be the fundamental or it may be the derived, you have to represent it in the form of LMT. That means the exponents I have not written. It can be L square, MQ, T to the power minus 2. In that form you have to represent it. Okay, otherwise it can be represented as MLT. That means the power of M I have not written, the power of L and the power of T, this to be substituted, then you can represent any of the quantities. Otherwise, if the temperature or the current is involved, then it should be represented as LMTKA. Now, it should not be remembered. Whenever you will just get this quantity, you know the mathematical expression. With the help of that, you can obviously represent. These things you don't have to remember. Just remember that what are the dimensions of the fundamental physical quantities. Okay. Look here. Here I have just made a table. That means the fundamental quantities, their dimensions and the representation I have just written. So that means the length is represented as L, but I have written M power 0, L to the power 1, T to the power of 0, right? Because whenever you are representing the length, so obviously the mass and the time will not be considered. It should have the power of 0, right? Similarly, when you measure the dimension of mass, it should be written as m to the power 1, L to the power 0, T to the power of 0. And it is having a representation of capital M. The time is having the dimension of capital T and it is actually represented as m to the power 0, L to the power 0, T to the power of 1. Similarly, for the case of temperature, it is having a dimension of K, and the electric current, it is having a dimension of A. Okay. By mistake, we have just written this one. It should be only A. Now, we are just going to understand that how the derived quantities, for the derived quantities, how to find out the dimension. Suppose we are finding out the dimension of speed. It is actually represented as distance by of time. Now the distance is actually one type of length that is traveled by the object. So it should have a dimension of L and the time is having a dimension of T. So the final dimensional formula, that is of L, T to the power of minus 1. Right? Now for the case of force, okay, it is having a mathematical expression as mass multiplied by acceleration. Right? The mass is having a dimension of m, but what is the dimensional formula for acceleration? It is actually represented as velocity, the change in velocity divided by of time. In this case, I'm just writing it down as simply velocity because I need the dimensional formula of that. Okay. So in that case, the m should be like that. The velocity is having a dimensional formula like the speed. Speed is expressed as Lt to the power of minus 1. So velocity should have the same dimensional formula. This is of Lt to the power of minus 1. Now the time is having the dimension of t. So after the calculation, we can say that the mass is having the dimensional formula of m, but the acceleration is having the dimension of Lt to the power of minus 2. So the dimensional formula for force, that is of mL t to the power of minus 2. So whatever the derived quantities I have already discussed in the previous slides, this is your homework, that you will find out the dimensional formula and you will just send it to me. So at this point of time, we are just finishing the lecture 1 and we will see you in lecture 2. Thank you so much. Keep revising.